So how do you do these things? Let me remind you again real quick. So the key to doing, first off, we're passing the -1 is going to go through two machines, right? Remember how this works? Like I made the comparisons, like putting my toaster in my refrigerator, right? So how would that work? I would take a piece of bread and I would put it in my toaster that's in my refrigerator. I'd push down the lever and then close the refrigerator door. So the toaster would do its thing on the bread, and a minute later it would pop up as toast. So the first function is done, and then the refrigerator would start cooling down the toast. And so a few minutes later, when I opened the door, I'd have chilled toast. Okay, so that's what's happening here. The -1 is going to go into the F machine. That's like into the toaster. And it'll pop up toast and then go into the outer machine, like the refrigerator. And whatever the refrigerator does to it, the final outcome is whatever both machines do to it, huh? Okay, so that's the basic idea of any composition of functions. How do we do that on a graph? Well, the key to graphs is whatever you put into any function, f, g, whatever, the input is x, the output is y. Input is x, output is y, meaning y values x values on the graph. So for example, any dot, like say this dot right here, what's the coordinates? I'll just grab one at random. What's the coordinates of that dot? That's over 1 up 2. And that's on the G graph. So that means you put a 1 into the G graph, you get out a 2. That's a y value. That's what any dot, any x, y dot on a graph means, input, output. Bread into the toaster, out comes toast. Frozen waffles in, out comes toasted waffles, right? Here's a point on the F graph. Well, what's the coordinates of that point? Over 2, down 3. That means you put in 2, you get out -3. So x, y on a graph are input, output in a function. And that was by common agreement. The math science world just said, hey, let's just make it this way. Whatever comes out of a function, we're going to call those y values. Whatever goes in, we're going to call those x values. Just what they did. All right, so with that in mind then, the -1 is an x value into the F graph. So look on the F graph, erase all this with me, look on the F graph, which is the bottom one, and tell me, where do you see an x value of -1, a point, a dot that has an x value of -1? That's right here, right? What's his coordinates? -1, 0, his x, y. So that means you put in -1 to the F machine, and you get out from the toaster pops a 0, right? So it'll put in -1, it'll pop out with a 0, comes out of the toaster, out of the F machine, and then you put that into the G machine, like now the toast is in the refrigerator. Put it in the outer machine. So if you put 0 in the G machine, so now look on the G graph and find the dot that has an x coordinate, right? Inputs are x coordinates. Input on the G graph of 0. That'd be this dot right here, huh? Over 0, up 3, x, y on the G graph. So that means you put a 0 into the G graph, you get a 3 out. So my final answer, out comes a 3. Did you guys track with all that? So you put -1 in the F graph, out comes a 0, because of this point, -1, 0 on the F graph. Then that 0 goes in the G graph, that's right here, 0 in the G graph, out comes a 3. Final answer, 3. Good? Questions? We'll try B. See if it's making sense for you. Try part B there.
Okay.
So part B, they switched the order. Oh no, same order, huh? G of F of 0. So try that one. I'll give you a second. See if you can get the final answer. Run that 0 into the F machine and whatever pops out into the G machine. X, Y points are inputs, outputs. Give it a try. It'll benefit you greatly to engage right now and give it a thought. All right, so if I put 0 into the F machine, where's that on the, where is an x, remember inputs are x values, where's the x value of 0, where's a dot on this F graph here that has an x value of 0? Well, this dot right here, huh? This is the dot that is over 0, what is it, down 1. That's the x value 0, y value -1. So that means when you put 0 into the F graph, out pops a -1 from the toaster. And then that goes into the G graph. So now go up to the G graph, and now we're putting -1 into the G graph. Remember, everything you put in is an x value. What comes out is y. So look on the G graph, find the dot with an x value, -1. That's right here, right? That's, what is that? -1, up 1, x, y on the g graph. So you put -1 into the g graph, out pops a +1, huh? The output. There we go. We good? Like you could do those. Remember, one of those two is on the test. What is it? Week after next? Something like that. Let's see. Yeah, week after next. When I say one of those, I mean either the graph one or the table one we did last time. Remember the table one? So one of those two is on the test. I really don't remember which one. All right, I'll move on. Okay, so we are on number 3. See if my pen's going to work. Yeah, all right, all systems go. Oh, it's not on the screen then, huh? All right, so we're trying to do now, this is number 3. There it is. Part B is part B. So g of f of 2. Okay, so first put the 2 into the f. So that would be f of 2. So that's 2 into this function. So it's 7 times 2, 14. Good so far. 14 pops out of the f machine. So then the 14 pops out and goes into the g machine. So now g of 14. So here's the g machine. 9 times whatever you plug in squared plus 1, huh? Is that good? And then just hit the buttons on your calculator. Somebody got that? Do you get that?
1,765.
1765.
Ooh, big number.
There it is. We good on that? Okay, so, what about f? Maybe we better do part C, huh? What about f of f? So part C, f of 1. So that's going to be put 1 into f, and then whatever pops out, you put into f again. Makes sense there? So put 1, so f of 1, it's right there. 7 times 1, 7. So you put 1 into the f machine, out comes a 7, and then that 7 goes into the f machine again. Right, exactly. Everybody with me? So again, when you put things in the f machine, it's 7 times x, so 7 times 7, out pops 49. Everybody good with that? All right. Okay, so number 6, what they want from us on this one is they want the domain of f of g. So all they're writing, notice all they're writing is f of g. They're not putting like a number on the right side there. So there's not a number over there. So that, right, they're not putting like a 2 or something like they did in the last example, so that I would run 2 into there and then the output into there. So they're not putting a particular number. So what does that mean I do? Well, I just put all of g into f.
Yep.
They just want me to do a general x, in other words. It's the same thing as if they really just put a general x. They're just saying, in general, we want to know what happens when g is put into f. We don't want it for a particular number. We just want to know, overall, if you put g into f, what do you got? That's what they want. Make sense? So I take all of g here, and I put it into f. Now, f has 2 holes for the toaster, right there and right there. So that makes sense. You put all of g into both those slots, because that's the input slots for f. So let's do that. So here we go. So it's going to be on the top and the bottom, -5. Is that good so far? So I'm going to put -6 over x, -6 over x. Is that good to there so far? Does that make sense what I did? I just stuck all of g into the 2 input slots of f. See how that was the setup of f? Something on the top, something -5 on the bottom. That's what f's setup is. Okay, so we get that. We good so far? Now, there's 2 things I want to tell you. Well, really one thing for now, another thing in a minute. Domain. They're asking me domain. What does domain always mean? Trouble spots, like you can't put tinfoil in the microwave oven. Things like that, right? You with me? For domain, we're always finding out what's allowed, what's not allowed. So, what's not allowed? What trouble spots are there?
Well, there's a fraction and a fraction.
So what are the trouble spots? What do we learn from domain? We've learned two things. Denominators may not be 0, right? Because if the bottom of a fraction is 0, that's undefined. So basically, and the other one was square roots, but we don't have any square roots here, right? So it's just all about denominators on this one for answering the domain question. You can plug any number, any x value you want into that function, except you can't plug any x number in that would make any denominator 0. So let's grab the denominators. Do you see that we have 3 denominators there? Now, what do I mean by 3? Well, that one and that one, those are the obvious two. So x can't be 0, right? No denominators can be 0, so those two are the same denominator. X can't be 0. And what's the other denominator? That whole denominator. That whole thing's a denominator. And that can't be 0. And that's going to be a little different. So minus 6 over x minus 5. The whole denominator can't be 0 either. You tracking with me? Mm-hmm. So no denominators can be 0. So that's what you do. So then you just got to solve this thing here. How do we solve that thing? What do we do when we got fractions? Multiply through by the common denominator, right? Or the only denominator. So that'd just be x. You with me? Multiply through by x, 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 and here it cancels. Good. That's how we handle fractions. Just multiply through by the denominator to get them out of there. We don't like fractions. We want to get rid of them. So then we get what? Minus 6, because the x is canceled. Minus 5x does not equal, what's 0 times anything?
0.
So 0 over there. We good to there so far? See how the x is canceled over there? And multiplied in the middle. Finish solving for x. Grab that negative 6, jump it to the other side. That's positive 6 or regular 6. Last step, divide by minus 5. So x cannot be minus 6. It doesn't matter. That negative on the bottom, you can just pull it to the front. You know, it doesn't matter where it's at in a fraction. So two things then. X can't be 0 and x can't be minus 6/5, which is exactly what the answer is there. See how they want you to say it? Just with a comma. Just put a comma in the two answers. Remember, if you're ever looking and you're not sure how they want, just hit the show me an example button. Hit enter, 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 go to the end. You'll see the format of the answer in case you're unsure. Good? Everybody see that? So no denominators can be 0. And the whole bottom is one of the two denominators. All right. Hey, soccer girls, how'd it go with Cerritos? You beat them. They scored, though, huh? Of course they scored. 3-2. Good job. All right. So you guys are ranked. Did your ranking go up based on that? Most likely will soon. Our women's soccer team is very, very good this year. They're top 10 in the nation already, right? And they just beat Cerritos. They're big. That's good to hear. Good job. All right. All right. So domain of the composite function f of g. So let's do the same thing. We're going to stick g into f. Right, they're not giving me a particular number, so it's the same kind of thing. Stick all of g into f. So all of g into f like that, right? So f is, something squared plus 4. That's the format of f. And we're putting all of g into f. So put in square root x minus 1. Does that make sense? That's f of g. I just put all of g into f. So far, so good? Everybody see that? Now, there's something I need to mention. That is this. Domain must be done before any simplification. Domain must be done before any simplification.
Okay.
In other words, what I'm saying is, if you went on to simplify this, and in a minute they're going to have us, this one they don't even care, but in a minute they're going to have us simplify. This square would cancel this root, wouldn't it? And it would be just x minus 1 plus 4, that'd be x plus 3, and that would be the simplified version. And they'll ask us for that, not on this problem, but in a couple problems down the line, they will. But you can't do that before you do domain. Domain must be done before you do any simplification. Why the big deal? Well, look, remember domain, what is the two things we look for? Denominators and square roots. Here we have a square root, right? If you have the inside of a square root, you take out the inside and you say inside. What cannot be in a square root?
Less than 0.
Yeah, can't have negatives because square root of negatives is imaginary, huh? So we say inside u must be greater than or equal to 0. You can't be negative. And that's what we do here. We grab that x minus 1, say x minus 1. Since you're inside of a square root, you have to be greater than or equal to 0. Jump the 1 over. X has to be greater than or equal to 1. That's the domain. That's what you would put right here, x greater than or equal to 1. But if you only went to the simplified version, you would never see the square root. You'd go, there's no square root. Well, the problem is there really is a square root. Even though I know back in your algebra, we got to think a little more advanced about math now. I know back in my algebra days, everybody's algebra days, we would just cancel these out and never think about it again. But now you're moving into pre-calc and calc, and you need to be a little more careful with math. Really, the square root's there. Really, it is. F of g really means a square root inside of a square. And I know we tend to think, well, yeah, it just cancels. Well, yeah, you can simplify it that way, that's true, but really it was there at some point, which means really you can't put anything in here that would make that inside of that square root negative. Even though it's squared later, it would be imaginary at first and not allowed. So you have to keep the original form before you clean it up to do domain. Then clean it up afterwards. Is that good? Makes sense on that? All right. So number 8, so f of g of x, so they want that. On part A, I've already given you the answer there. Let's go ahead and do it. F of g, and this time they're putting x, that's the same thing. When they do x, it's the same as putting nothing. It just means plug all of g into f. Notice it's not any particular number, right? It's just x could be anything. So it's just all of g, pop it into f. So if I take all of g and put it into f, it becomes 7x. You don't need those parentheses, but there it is. That's what we got. Pretty straight ahead, right? That okay? And now, excuse me, I want to answer the domain question for you. What is the domain? Well, do you see how I checked that the domain is all real numbers? Because there's no problem areas. Everybody see there's no problem areas there? There's no square roots, so there's no roots, no denominators. Then that means there's no problems. No problem. Nothing to avoid, so all real numbers. Meaning you can plug any number you want into that machine. There's nothing to worry about a problem. No denominators could be made 0. No negatives could be made inside of a square root. Because we don't have denominators or square roots. Good? On that? And then they have you do the other way. They want g of f and f of f and g of g, and it's all the same stuff. By the way, they're all going to be all reals for the domains because there's no square roots. There's no denominators anywhere. Okay, so make it a little bigger if you can read it. F of x is 9 over x minus 7, and g of x equals 1 over x. And they're asking us for f of g of x. So again, that just means generally put g in f, because there's just x. There's no particular number. So put all of g into f. Let's do that. Put all of g. So all of this is going into f. Like that, right? And then, so you put in that 1 over x, like that. Is that good so far? I just put all of g into f. Now, 2 things need to be done. We have to clean it up. We have to see, it says here, simplify your answer. So, we can't leave it this way because this is called a complex fraction. It's fractions within fractions. It's a little bit messy. Got to clean it up. It's not that hard. But remember, we don't clean up first. What do we do first? The domain question. Even though it's kind of confusing because they first ask us for the cleanup and then they later ask us for the domain. But we have to do domain first. You have to do domain before you simplify, because otherwise you can cover up trouble spots with the simplification. So yes, let's do the domain right now. So let's come on up here. Can you do that? Let you try it real quick. So go ahead before you simplify. We'll simplify in a minute. But first take that thing and do the domain. There's 2 denominators there, right? There's the little denominator and the big denominator, and both of them not equal to 0. Because denominators cannot be 0. Making sense? So, this little denominator here, that can't be 0, and then the whole denominator, right? Can't be 0. So 1 over x minus 7 can't be 0. Is that good? No denominators are allowed to be 0. So now solve that second equation. The first one's done. Solve the second equation. How do you solve that second equation? What do you do with fractions? Multiply through by the denominator, right? Multiply through by the denominator. So let's multiply through x, x, x. Multiply on through. Is that fun? Boom, cancels down. 1 minus 7x cannot be 0. Good so far? And then grab that 1 and jump it to the other side. Like that. Divide by minus 7. So x cannot be 1/7. So x can't be 1/7, and x can't be 0. Those would be right here. You know, we'd say x cannot be 0, x cannot be 1/7. Any other numbers are fine, but you can't put a 0 into this machine, and you can't put a 1/7 into this machine, this composition machine, right? Where we're composing, like when they compose music and they put several instruments together into a composition. That's what we're doing with these functions. We're composing them together to make a new creation, a new function out of the two, and we're saying you can put anything you want into this function, this new composition function, but you can't put in 0 and you can't put in 1/7 because that'll make it choke. That'll make one of the denominators 0. Anything else is fine. Okay, now, so we good to there? Now we have to simplify. You can tell I got this answer right here. How did I get that? How do we simplify when you have fractions within fractions? That's messy. We don't want that. How do we simplify that? Well, we multiply. We do what we always do. You multiply everybody by the denominator, which is this little x. He's the denominator within the fraction, huh? I mean, he's the little denominator. You multiply everybody by the little denominator. So that means top by x and all the terms on the bottom by x. Why does that work? Because that'll make this cancel right here, huh? Because that's over 1, really. And that'll get rid of our problem. See how that works? That's what you always do. You got fractions over fractions, just multiply through by the little denominator. But I'm doing the same thing top and bottom, so I'm not changing anything. I'm just changing the way it looks. Does that make sense? I multiplied top by x and all the terms on the bottom by x. So I'm really multiplying by x over x, which is a fancy 1. So I'm not really changing anything in the end. Not any values. I'm just changing the way it looks, right? All right, so then what do we get? 9x on the top. On the bottom, these cancel, and you get 1 minus 7x. That's how I got that there. That's the simplified version. How we doing?
Yeah.
That all making sense? So we simplified it, and we found the domain. Questions I can answer? All right. So f, so they want f of g, so that means put g into f. Put all of g in it. So give that a try. Let me let you'll get more of it if you try it first. So try it on your own papers there. Put all of g into f. All of g into f. See what you get. And then do the domain first, right? Put all of g into f, and then before you clean up, before you simplify, do the domain, which means all denominators not equal to 0. This one's going to be a little ugly. All right, so I'm going to put all of g into f, those two slots, right? Into the x slot. So, what do we get? We get something plus 4 over something plus 7 minus 4, huh? And what are we plugging in? Plugging in g, which is x plus 5 over x minus 8. X plus 5 over x minus 8. Good? So there's f of g. Now before we clean it up, We will clean it up in a minute. In a minute, we're going to multiply everybody by x minus 8, because that's the little denominator, huh? In a minute. But first, let's do the domain question. So what do you do for a domain? Circle every denominator, little and big, and set it not equal to 0, as you know. So we got x minus 8 not equal to 0. That's an easy one. So x is not 8. And then the entire denominator. X plus 5 over x minus 8 plus 7 not equal to 0. We good? You guys tracking with me? I'm not doing the Charlie Brown teacher voice. Am I lulling you to sleep now? You tracking with me?
Mm-hmm.
Is this all good? Now, how do you solve that? Multiply through by x minus 8, right? Whenever we have a denominator, what is the denominator? X minus 8. To solve it, you multiply through by x minus 8. So x minus 8, x minus 8, x minus 8. Cancels here. Good. That's how we always handle fractions, huh? Just multiply through by the denominator. Getting the hang of that? That's getting easier and easier. Do a lot of that if you go into calculus. So where does that leave us? X plus 5 plus 7 times x minus 8 not equal to 0. Because, right, 0 times anything is 0. All right, distribute this. X plus 5 plus 7x minus 56 not equal to 0. Gather like terms. X and 7x is 8x. 5 minus 56 is minus 51. Bump the 51 to the other side. X is not equal to 51. Divide by 8. There it is. X cannot be 51/8, and x cannot be 8. There's the domain. We good?
Okay.
On the domain. It's messy algebra there. But if you're going to calc, that's exactly what you'll do a lot of. That kind of messy stuff. Good, and then we got to go to the middle one, and now we got to simplify this mess right here as well. Everybody good with the domain? Questions on that? You okay with how I handle, right, whenever you have a denominator, you just multiply through by that denominator. Just gather like terms and solve for x. Okay, now over here, we have to clean this up, because this is fractions over fractions. This is called a complex fraction. Can't leave fractions over fractions. What do? You multiply by the whatever's causing it to be fractions over fractions, which is the denominator. X minus 8, x minus 8. That's the little denominator, right? So just multiply through by that little denominator. Everybody, top and bottom. Because you got to be equal treatment so you don't change anything. Is that good? Multiply everybody, top and bottom. So we're not changing anything, just going to change the way it looks. X minus 8's cancel. What do we get here? We get x plus 5 minus... Oh, and I'm going to distribute that minus 4 through right now. Watch out, that minus 4, it's easy to lose the minus sign. Remember, that minus is on that 4. So minus 4x plus 32 over, on the bottom, x minus 8's cancel. X plus 5, the plus 7 distributes, plus 7x minus 56. And that cleans up. We good so far? Everybody see how I'm getting that? What is that going to be? Minus 3x plus 37 over what? 8x minus 51. Excuse me, if I was going to sneeze, I guess not. Okay, so there we go. We're done. Is that good? Questions on that one? All is well? All right. Can I flash off that? You function in the other. That's all they are. It's a bunch of fancy talk for do the same thing we've been doing all section. So let me show you. So it says blah, blah, blah. You don't need to read all the words. Just grab this. S of r is 4 pi r squared. And then grab this. R of t equals 2/3 t to the 4th. And what do they want from me in the end here? What they want, the question is S of t. I don't know if you ever spend much time thinking about that letter that comes after the main letter, the plug-in letter in the parentheses, but that's what this one's all about, so maybe it's a good time to spend 1 minute talking about what that means and what that does. So basically, the letter that's in the parenthesis in any function, whatever letter's in the parenthesis, that's what it is a function of. That's what's called the independent variable, and the s is the dependent variable. Meaning, that you give me an r value, because if r is 3, then you plug that in and you can calculate s. S is surface area here. They're blowing up a balloon, like a big hot air balloon, right? So they have it on the ground and they're pumping, they're filling it up with the air. So this hot air balloon, S means surface area. So as the balloon fills up, its surface area grows, right? As its radius grows. So they're basically saying, this formula is basically saying, you tell me the radius, okay, radius is 3. I don't even know what the units are for radius. Meters. So you tell me the radius is now 3 meters. Okay, I'll plug that 3 in here, square it, 9 times 4 pi, 36 pi. 36 pi is the total surface area of the balloon when the radius is 3 meters. That's what they're saying. That's a formula that you plug in an R, they'll tell you a surface area. You plug in an R, that's called the independent variable. You don't have to know these names, but anyway, that's just, that could be anything, right? R could be 2, R could be 1, R could be 3, R could be 17, whatever. Just does whatever it wants to do. And the S responds. That's called dependent, right? S responds. Whatever R does, S says, oh, if you're 3, okay, I'm 36 pi now, right? Because 3 squared times 9, times 4 is 9 times 4 is 36. So, right, see how S responds? He's dependent, we call it. So R is so the one inside is always the independent, and the one outside is always the dependent because it responds. So now, what is this little formula? Well, this is the radius at any time. In other words, what they're doing is they're filling up this balloon. So over time is in seconds. So you tell me how, because right now, the pump is filling up the balloon. So you tell me, like, okay, 2 seconds after beginning to pump air in, what's the radius? Well, plug in a 2 here to the 4th power times 2/3. That'll be the radius. Make sense? So give me any time you want. That's independent variable. And I'll respond with the dependent radius. Okay. Now, what they want here is they want to know what's the surface area at any time. That's what you'd really want to know, right? Start pumping this thing up. Start the pump going. I want to know 10 seconds later how much surface area there is. How are you going to do that? Well, do you see? It's all a bunch of fancy talk for saying take this and put it in there, right? Because when you do, right, because this is the radius, this is R. This is R, right? This is the radius, so plug it in for R right here. So you get 4 pi R squared, and what is R? 2/3 t to the 4th. Do you see how I get a formula with t? That's what they're asking. Give me an S formula with t. Got it. I just got to clean it up a little bit now. Does everybody see that? So that's, that's what you'd want. That's how you'd relate those. So let's clean that up. That's going to be 4 pi. And then how do you square all of this? All of that is squared. You square every piece. 2 squared is 4. 3 squared is 9. T to the 4th becomes t to the 8th, huh? Good there. I just squared everybody in those parentheses. And now, what do you do with 4 pi times 4/9? Well, whole number's over 1. So 4 times 4, 16 pi. All goes in the top. 1 times 9 on the bottom. T to the 8th. There we go. There's S of t. There's the surface area at any time. So really, it was just plug one function into the other, wasn't it? You could find out what the surface area of that balloon is at any time now. Good? On that, no questions? Is that okay? All right, I'll move on and be on the YouTube. They're not real word problems in the sense that you don't have to really look close and be all careful. It's just, hey, here's an n of t function. So n of t is 700t minus 10t squared. And then they got this other function, c of n. C of n, that's how we say functions, right? C of n is 40,000 plus 8,000 n Okay, so what do you want me to do? Well, they want C of t, notice. What they're asking for in the end is C of t. So the outer function C that they want. So that means I'm going to take this one and plug it in there, right? Because the outer one is the C. So you plug into the outer one. Makes sense? Which way to go? So that means it's 40,000 plus 8,000 times whatever n is. And what is n? N is 700t minus 10t squared. And I'm going to go dot, 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 distribute, clean it up, and you're done. Is that good? And that'll be, see, that'll be just have t as its variable. That'll be c in terms of t. They're going to make you FOIL this probably and gather like terms. I don't know, maybe you try typing it just like that, see if they'll take it. I don't know, probably not. They don't say simplify though, do they? So maybe they would take that straight. I don't know. All right, so I'm gonna leave the last one.